So hey guys, so now in this video we'll be doing about degrees of freedom, the importance of degrees of freedom for these molar properties, and then the partial molar property of a pure substance. Okay, so now one thing which I want to tell you is that when you take the partial molar property of a substance, taking this mi bar, so I'll take it as differential of the actual molar property with respect to number of moles Ni, and then having temperature, pressure constant, and then you'll be having Nj which is not equal to Ni, which is in the case of a binary solution. Okay, this is the actual definition which you have learned. So now one thing which you need to know is this molar property which is taken is an extensive property which you have already discussed, right? We've already discussed that it should be an extensive property. It can be volume, it can be Gibbs energy. Okay, so now these are a few examples. And then number of moles, again in the first video itself I must have explained the number of moles is an extensive property. Number of moles is an extensive property. So now when two extensive properties are divided, you will be getting an intensive property. So from this we come to know that any partial molar component or any partial molar property is an intensive property. That means this partial molar property will not depend on mass. It will not depend on number of moles. The actual molar property is the one which will change with the change in number of moles. This change is described by the partial molar property. Okay, this change in the actual molar property when the number of moles change, you would describe them with the help of partial molar properties. Okay, so now as we said, in an intensive quantities, will not depend on mass, but then it will definitely have certain other factors with which it will depend, or with which it will change. Okay, so how do you determine the number of factors with which it will change? You use the concept of degrees of freedom to determine this fact. Okay, so now here degrees of freedom is supposed to be f, and then here p is supposed to be the number of phases. This is supposed to be number of components. Okay, number of components. So now we are considering the case, like in all these cases where we discuss the basic, the fundamental property equation, or the summability property, or the actual definition of partial partial molar properties, we have considered only a binary solution, and then with a single phase. Single phase binary solution is what we have always been considering. So consider P is equal to 1, C is equal to 2. So F equal to 4 minus 1, which is 3. There are totally, with the degree of freedom is 3. That means there are 3 properties with which this intensive quantity is dependent on. Okay. So now let us consider any molar property Mi. So now this any molar property Mi is dependent on 3 factors, because the degree of freedom says it's 3. The factor is temperature, pressure, and then the mole fraction X. And I already said mole fraction I can also write it as Ni, but mole fraction will give you a holistic picture which will bring in all the other number of moles also into the scenario. Okay, so now in case if it was too fast, let me just repeat. Degrees of freedom is always used for determining a number of factors with which an intensive property depends on, in this case and in this scenario alone. So when you find degrees of freedom in the case of a binary solution with a single phase, you will get degrees of freedom as 3. That means 3 factors are involved. We have considered that as temperature, pressure, and mole fraction, or I can write this mole fraction in the terms of number of moles alone if it is a proper binary solution. So now I am generalizing it and writing it as mole fraction. So now let's talk about the partial molar properties of a pure substance. Okay, so now we'll talk about the partial molar properties of a pure substance. So now for that, let us consider the actual condition. First, let's consider the normal condition, which is M1 bar. So now here one more change which I am making is naming the two components as 1 and 2 instead of I and J. So M1 bar is equal to Nm dou Nm by dou N1 at constant temperature, pressure, and N2 is not equal to N. Okay, these are the conditions, and I'm using the factor Nm because I will tell you why. Now we are having a holistic picture, so we are considering each and every molar properties change. Okay, so now this is the condition. I think I'm taking this as N1 because we are considering N1 number of moles all throughout. Okay, so next one is we are considering the fact that N1 is equal to N and M1 is equal to M because it is a pure state. Pure state means you just have only one component which will be crystal clear. Just one component. So now just substitute this everywhere. Okay. So you will have m bar is equal to dou n m by dou n, and then temperature and pressure. Okay, just temperature and pressure. So now one more thing which you need to know is this m will come out as a constant. So m bar equal to m dou n by dou n. Okay, it will come out as a constant. So now m bar will be equal to dou n by dou n. This and this will get cancelled, and then afterwards you'll be left with m bar is equal to m, which means in a pure condition your partial molar volume and the actual molar volume will be the same. Okay, let me repeat once again. This is why I took the whole took n the number of moles into this whole picture. So m1 bar is equal to dou n1m by dou n1, and then afterwards I'm considering the fact that it's a pure state, so then n1 will be equal to n, m1 will be equal to m, because only one substance is there, only one component is there. Again, I'm substituting all those factors. M comes out as a constant from the partial derivative, and then afterwards you'll be left with m bar is equal to m. Okay, so now we have done all the basics. Now let's go to the details of every property. The first property which we'll be discussing in detail is the partial molar volume. So now this is a very short video. All the concepts have been cleared. So now let's go on with the partial molar volume in the next video. Okay, thank you.